All right, this problem wants us again to find a derivative. Here, though, it's not product rule. This isn't two functions being multiplied to each other. Otherwise, it would look like this. Here, function g is actually inside of function f. So when you have a function in a function that's composition, we need to use a different rule, and that rule being chain rule. Chain rule, to find the derivative, you want to take the derivative of the outer function, evaluate it at the inner function, left it alone, we don't do anything to it, times the derivative of the inner function. So let's see if we can apply that back to this problem here. So our derivative of function h is going to be our outside function here, which is f. So derivative of f. We leave g alone. We don't do anything to that one right now. Times the derivative of this inner function. So derivative of g. Okay, so now if they want us to find this at 3, anywhere there's an x, plug in a 3. Okay, so now you want to figure out from the table values what these would be. Now you got to be careful here. We can't just plug in all the values right now. Like if you just did derivative of f is 7, this is 4, and this is, what would it be, -2, that's incorrect. We don't know what that f1 is right now because we don't know the value inside here. We don't know what this equals yet. We got to find that out. So go to the table, find that one. G at 3 is 4 from the table. So now that we have that value, now we know what to evaluate f at, which is 4. So we know that one, and we also know what the derivative of g at 3 is that one. Now we can come up with our solution here and get the answer. So this would be -1 times -2, or the answer comes out to be 2. So be careful on those problems with chain rule. All right, let's take a look at another chain rule one. We want to differentiate x cubed minus 1 to the 100th power. This would be a very long problem to do if we had to do it with product rule by multiplying out 100 of these and trying to do it that way. Very, very difficult. Take you a long time. Chain rule makes this one a lot easier. You just have to be able to identify what's the inside function, what's the outside function. Inside functions, what's in the parentheses here. Our outer function is something being taken to the 100th power. So we start with the outside function, do the derivative of that. So anytime we got a power, we bring it down. New power becomes 1 less, so 99. We don't touch the inside one, leave it alone, just write it as the same. But now we do times the derivative of that inner function. So derivative of x cubed is 3x squared. Derivative of 1 is 0, so the derivative would just be 3x squared. That's the answer. In this case, we could multiply these two together to make it a little bit simpler. We can't multiply it with this because there's an exponent on there. So the way you see it on an exam would probably be written as this. So that would be our derivative right there. All right, let's try another one. Differentiate this one. Now in the last one, our exponent was our outside part. In here, it's actually our exponent's going to be our inside part because that's inside of this exponential of e to some power. So e, or our exponential here, is the outer one. All right, so finding this derivative now, start with the outside one. So derivative of any exponential with e is the exact same exponential, so the derivative of the outside part is e to something with leaving that inner function the same, sine x. But now we got to do times, what's the derivative of that inner function, or what is the derivative of sine x? In this case, it'd be cosine x. And there's no way to simplify that one, so that would be our solution there.